What's good, YouTube? Back at it again with another video. I'm Bruce from Jump Mathematics. In this video today, we will be covering some of my favorite theorems, the mumbling theorems. Why the mumbling theorems? The derivative of a constant times a function is a constant times the derivative of the function. The derivative of a sum is the sum of the derivatives. We're going to go over the proofs today. Why are these my favorite theorems? Well, first of all, they've got the cool name, the mumbling theorems. Second of all, they are the most commonly used theorems in all of taking derivatives because you almost always have a constant times a function and you pretty much always are adding functions together when you're differentiating them. And you might have noticed when I was pronouncing the theorems, actually, I had a little bit of difficulty saying them. So first things first, we're gonna prove that the derivative of a constant times a function is a constant times the derivative of the function. Let's see what that means. So first, the definition of a derivative. D by dx c f of x equals. So this is our function right here, c times f of x. So this is c times f. Even I forget it sometimes. Lim h goes to 0, c times f of x plus h minus c times f of x all over h. Right here we have a common factor of c, so let's go ahead and pull that out. Lim h goes to 0, c times f of x plus h minus f of x all over h. So let's see what this is. The c, first we can write that out here. C times whatever the limit of the rest is, because it's just a constant. Limit as h goes to 0 of f of x plus h minus f of x over h. That is the derivative of f. D by dx f of x. That's the proof. So what we just showed, the derivative of a constant times a function is a constant times the derivative of that function. What that means, if you ever differentiate, you ever have like a 5 times your x squared, 5 times sine x, whatever. All you have to do is write the 5 down and then you go ahead and differentiate what the function is. That's what this says. The derivative of a sum, so let's go ahead and calculate. D by dx f of x plus g of x is equal to lim as h goes to 0. So this is going to be f of x plus h plus g of x plus h minus f of x plus g of x all over h. So let's rewrite this a little bit. What I'm going to do is I'm going to take this factor and this factor, I'm going to write those together, and then I'm going to take this, and I'm going to write those together. So let's go ahead. This limit stays. Limit as h goes to 0. I'm going to write f of x plus h minus f of x. That takes care of this and this factor. My plus g of x plus h minus g of x. That's this factor and this factor in the blue. All over h, well, I'm just going to write them both over h. Because I had a common denominator and I'm going backwards, adding these fractions. So then this is equal to, of course, I'm going to distribute this limit into both of these. Lim, because I have the limit of a sum, is the sum of limits. Maybe we'll prove that in the next video. H goes to 0. F of x plus h minus f of x all over h plus lim h goes to 0, g of x plus h minus g of x over h. What is this? That is d by dx f of x plus, what is this? Of course, that's just d by dx g of x. So let's go over what we saw today. The first thing we saw was that this rule, how to differentiate a constant times a function. the derivative of a constant times a function, we went through, what, a 3-step proof to see that it was the constant times the derivative of the function. All you have to do is write the constant down and then go ahead and differentiate like normal. The derivative of a sum is the sum of the derivatives. We started with f of x plus g of x that represents the sum of any two functions. We did this definition of derivative, then we rewrote the terms, the f terms first and the g terms second. Then we distributed the limit, and we saw right here that the first limit we had was the derivative of f of x, plus the second limit was the derivative of g of x. I hope you enjoyed this video. Remember these tips right here, that classic blue box. You're going to be using these every single day of differentiation for the rest of your differentiation life. Hey, what's going on, guys? Thank you for watching the video. If you're interested in getting better at math by getting all kinds of practice, what I want you to do is go to jumpmathematics.com. Here I provide you with free instructional videos and hundreds of practice problems. This is the best way to get better at math by doing practice problems. See you in the next video.